Good morning, everybody. We made it to Thursday. I'm really excited today to be streaming about Kubernetes, specifically running WebAssembly in Kubernetes. We're going to be using the Krustlet library, which is written by the Deus Labs team at Microsoft Azure. And I've been having a lot of fun contributing to both Krustlet and some of the upstream projects with WebAssembly's secure capabilities, waSCC, that allows us to do remote procedure calls over WebAssembly. So what I'd like to do today is build a waSCC actor, which is the core of a waSCC provider. It allows you to create a service that you can then host with a WebAssembly runtime. And we're going to run it in Kubernetes. I'm going to run it in the Kubernetes that's supplied in Docker for Windows. So I've installed the latest Docker for Windows beta and enabled Kubernetes, and then enabled the WSL integration so that it works inside my Ubuntu WSL instance. So if we type docker ps, we can see that there's all kinds of Kubernetes containers running, which means we've got some Kubernetes action. And we can type kubectl get pods. And there's no pods running. So we've got a Kubernetes instance and we've got some code. So let's make an actor. I'm going to actually contribute this actor as a demo under the waSCC folder in the Krustlet repo. So I'm going to create a new branch. Create a new folder for our actor. And I think we're going to do something pretty simple because my Rust is not very strong. And we'll do an uppercase thing. So we'll send it a string and it'll return the uppercase response. It's still going to stretch my capabilities, so don't laugh. All right, so we need a cargo toml file. Let's go ahead and create one in there. We need a git ignore. I like a Makefile for these actors because there's a lot of actions that you have to do to sign them. Nothing makes me happier than a good Makefile. We need a source directory. All right, so I am going to make a package here. If it's going to let me type, oops, I want my cargo. There we go. We'll use the 2018 edition of Rust. And this is important. We need to set the crate type to a C dynamic library. That way we get the correct WebAssembly function headers. I don't know if those are the right exact words, but it builds the function table in WebAssembly the way we expect it. For dependencies, we're going to use waSCC actor. And the latest version of that is 06. And that's a Rust library that allows us to make remote procedure calls that the waSCC host will execute. I'm going to use JSON as a response. So we need some serialization here. I don't know how to say serde, S-E-R-D-E. I'm sure there's a correct way, and I'm sure I don't know what it is. But I can tell you that it is magic. All these macros, the derive macros, love them. All right, and then the last thing we're going to do is optimize for small code size. So we'll create a release profile. All right, so let me move into that directory. All right, we need a lib.rs file in our source. All right, and in that, we're going to want to import our actor library. So let's add the waSCC actor crate, and let me go ahead and pull that documentation up for you. So you can see here, waSCC.dev is the website that has the information about the waSCC runtime and waSCC actors. You can go through the tutorial to create your first actor. That's roughly what I'm doing, except on the other screen over here, I'm cheating and copying a different actor that I already created. So we can follow along. It's also possible to do a cargo generate. Thank you, Kevin, for reminding me. We could do cargo generate with a new actor template like that. But I'm not going to do that today. All right, we want to add logging. So we'll let it use macros for logs. Serialization. Now, the way waSCC works is it uses basically remote procedure calls from the host into the actor, and it serializes and deserializes those messages between the two. The messages are in a certain pre-configured pattern, which is in the waSCC codec. So we know that we're going to do a host call, and that host call is a specific kind of call, and those are all predetermined in the waSCC codec. The codec. So we'll pull in all of the actor code. And we use all the logging library. All right, now here's the fun stuff. we're going to create a handler. And that handler is just a function. So let's create a function called uppercase. And the uppercase is going to accept a request. And that request is actually a struct in the codex. So and it's going to return a call result. Oh, there we go. Got to name my variable, my input. Okay, so it's going to return a call result, and the call result at a minimum needs to return OK. And then we need to tell the actor runtime that we've actually got handler here. So we're going to use the actor handler macro. So we'll tell it that we have an HTTP request, and we're going to map that to the uppercase function. And then we also need a health check macro, or a health check function, so we'll add that, and I'll go ahead and declare it here now. That's defined in the core library. Let's go ahead and put together a health check function. This is going to accept a request that we're going to ignore. And it's going to return a receive result. And we'll just say OK, and an empty vector. All the macros. All right, so in theory, this might build. Oh, I need to add it to the members of the parent here. Hope that works. It does. I think it's really cool that you can have multiple crates inside of a single project and have this parent-child relationship. That's kind of slick. I like the way that's done. All right, so we had an error. We expected a parameter in our result. Well, that's okay. We're going to add a result anyway. So let's do, let's create a response type. And we'll put it down here. Like so, an upper response. Let's call it uppercase response. Just for a little bit of consistency. And let's add original as a string and upper as a string. We want to be able to serialize this. So we use these killer macros in Rust. I could spend a whole week or two just diving into how to make macros in Rust. I love metaprogramming, and that looks like a ton of fun. Hi Nuno, good to see you. Thanks for joining in. Okay, so we can access the body of our post, and we can access the query string in this uppercase function by accessing this request object. So let's do something simple. Let's start off simply with something like the query string. Let's make a new response. And we want, all right, we've got original. Oh, some methods. There we go. What's my problem here? Expected semicolon. Okay, now we need to serialize our response as the body of our okay here. So we'll just do serialize upper. And let's see if we can compile some stuff like magic. We can. So it builds, but it's got some errors. We never used any logs. So let's add some logs. And let's start off by logging this request. So I know this request type. No definition. Well, let's go to the codec and find the documentation for this. All right, so the query string is just a string, and it's the string portion of the URL. So let's grab that and let's log it. Let's do info. The field. All right, so now we've got logs, and we know that the original is our .query string. I do wrong? Oh, semicolon. Much better. Semicolons killing me. All right, build it again. We're not using the direct logging library, so we can get rid of that. All right, so we built it. I'm going to go in and copy this Makefile because it's got all the goodies that I need to build this properly. And I'm all about cheating. My dad used to say, if you're not cheating, you're not trying. I'm not really sure if that's a life lesson or something we need to live with, but that's okay. So the important things in here are the target. We want to target WASM32 unknown unknown. So that will give us a WASM library, not a WASI executable. Let's change our version to 1. The build is going to cargo build and then sign it using waSCC. So let's see here. Where's our target? Oh, this will be interesting. I'm going to comment that out for now. I'm not actually sure where it's going to end up. All right, so important parts of this are that we need to have keys to do signing. So waSCC is a utility, and let's go demo that by, let's see, where is, I'm gonna open up a new terminal here. So if we go look at a actor that I've already built, an actor here. All right, so I built this actor test logging.wasm, and then this Makefile signs it, and it signs it using keys that we generate. And those keys create a private and a public key, and then embed the public key information using a JWT token inside the WebAssembly file. And that's important because there are declarations about who created the WebAssembly actor and what capabilities in the WASC runtime can be accessed with that. So once we create the keys and sign it, then we are going to push it to a Docker repository. This one's going to be an ACR. And we'll give it a new name because we don't want to use greet WASC. We're going to call this one uppercase. And again, this directory is going to be wrong. So here, let's do waSCC. Oops. So this gives us the capabilities of the actor that's embedded in this WebAssembly module. You can see there's an account key and a module key. This is the public key of the module. It has no expiration, so it can be used immediately, and it's got no version number embedded, no tags, but it has declared that it wants to use HTTP server and logging capabilities. And that declaration happens when it's signed up here. So in the signing, we declare -S and -L, which are shortcuts for HTTP server and logging capabilities. So we need to do the same thing. We need to generate keys and sign our actor here. So first thing I want to do is a cargo build, a make build. This thing separator, I guess we can't have nice things when we paste. While I'm doing this, it's important to note that we can't push, what am I doing? We can't push these WebAssembly files to just any Docker registry at this point. It only works with a few providers. ACR is one of them, and honestly, I don't remember the list of others, but it's ones that allow you to send a MIME type that's different from a typical Docker container, because a typical Docker container is a tar file, and actually we're just sending WASM bytes up. So if the registry supports that, you can send WASM up as a Docker file, and that's using this WASM to OCI binary, which is at engineered. WASM to OCI. So this is just a Go binary that pushes up WebAssembly modules into OCI registries. You can see it works with distribution and ACR. Not sure about any others. But that's good for us because we're going to use ACR. All right, so now I've got target. Oh, Kevin's pointing out in the comments that I need a cargo config directory. So let's add that. So and in the cargo config directory file, we're going to tell it thanks for pointing that out, Kevin. That's important. All right. Now we're building with the right target. And that should show up in our WASM32 unknown unknown. And it is. And here's uppercase.wasm. Hooray. So we can go back to the Makefile. There's a handful of keys things here, keys targets. There's keys account and keys module. So it's going to create keys for the account and keys for the module specifically. So let's do make keys, header.keys, that'll work. as long as it's ignored in Git. We definitely want to add that. All right, so now we're ignoring the keys directory. We don't want to push our keys up to GitHub, that'd be bad. So make keys. That creates keys directory. It creates a public key, and the seed is our private key. It doesn't matter for this because we're not doing anything secret. And then the public key is the thing that we are able to read and embed in the WebAssembly file. So now we have our keys. Go back to our Makefile and fix up our build so that we're signing the right thing. Let's see here. So the target is going to be from up 1, 2, target, so up 1, up 2, we need up 1 more. And this is called uppercase. And the output file is going to be uppercase signed. And we'll give it the right keys and logging plus HTTP, and we'll call it uppercase. Let's see if we got the signature right. We did. We got all the directories right. First time. Amazing. All right, so let's go fix the release. Be the same. That part should be all right. So let's just fix names. Good. And then let's change our push here. And we need to get the right number of directories. Should be it. In order for WASM to OCI to work, it needs to be logged into the ACR registry, which I hope I've already done. So let's try a make release. While that's compiling, let's go into our demos and look at the Greet demo. You can see this Kubernetes manifest for the Greet WASC demo here. I'm just going to copy it and add it to uppercase. Probably need a nice README in here too. Let's copy that one. this. All right, so our release seems to have worked. Let's see if we have a release target. We do, and we have a signed WebAssembly file. So let's go into our other directory here. Krustlet target. All right, so let's do a waSCC. And it is signed, and it's got the correct capabilities, and it's got a nice name. So it looks like everything's fine with our capabilities and our signatures. Kevin's telling me that our module isn't going to return a valid result because why? Return value from a handler needs to be an HTTP response. Oh, that's bad. Let's go look at those docs. It looks like we need to create a response to response JSON. So we can do something like this. I need more question marks in there. Function takes 3, but we only got 1. So JSON takes a payload, a status code, and a status. That's JSON status code. And a status. I wonder what the status should be. Okay. Oh, I definitely have this wrong. Oh, I know what I need. I need OK. Then serialize. Oh, gee. Kevin's telling me too. Serialize response. Okay. Something like that. No semicolon. Whoop. I still don't know what I'm doing wrong here. Serialize returns a result. Huh, magic. It's the Rust question mark. All right, so let's make this again. Looks good. Let's release it. Good thing Kevin's watching. I've been digging around all day looking for a question mark. You notice I'm not actually building the result here. That's because I don't know what the query string is going to look like. So, and maybe I want to use the body instead. I'm not sure. If we post in to the body, then we'd have to read the body. Query string might be easier. So let's see here. Let's go ahead and push this. And in order to do that, we need make push. Sure we got a small version number. We do. Scope authorization failed. Guess we better log in. Wish I could move the camera and show you my dog staring longingly at the window of my office. Feels so excluded right now. Okay, so we pushed this WebAssembly up to the Azure Container Registry. Let's double check the manifest for Kubernetes and change all the things. All right, so what we're specifying is that we want to create a pod with one container, the uppercase container. It's always going to pull the image. The name is going to be uppercase. It's going to support, it's going to listen on port 8080. And it will only run on nodes that have WASM32 WASC tolerations here. So let's try to run our couplet. And that's in the parent directory here. We want to do just run WASC. And in order to do that, we need to be in the root. And in order to get the logs, we need to know the IP address of the node so that Kubernetes has the ability to make a REST call into the couplet and get the logs for that particular node. So let's figure out what our IP address is. And I'm on WSL2. My IP address is this weird one here. So I can do export my node IP and just run WASC. So let's look at We have no pods running. So let's apply this manifest to our Kubernetes instance. Remember, Kubernetes is running Windows Kubernetes, which is inside Windows for Docker, and it's Kubernetes instance. So let's do kube control apply -f. Says the pod was created. Let's go back and look at the logs. And you can see pod, I have too much debug code in here. Pod was submitted, and it starts. The actor is sent to the WASC host. Here's the public key of that actor. It has configuration that requests the capability for HTTP server and logging. So it binds the actors to both HTTP and logging. And then it says it's going to try starting them. Container state running. So it looks like it ran. Let's do a get pods again. And it says it's running. So if we curl '80, and let's pass in some query string. Perfect. So we sent in a query string, we got back this response, and now I know what the query string looks like. Let's go fix our uppercase code. This is so exciting. All we have to do is uppercase. Try something like that. Builds. Build it in release mode, sign it. Let's bump up our version in the Makefile to 0.2 because now it actually does something new. Push it up to ACR. I'm going to start Krustlet again. That's interesting. It says the pod's still running even though I just killed Krustlet. It says the node's still there too. All right, no pods, no nodes. Let's start our Krustlet over. So that's probably a bug that I need to file on the Krustlet repo. All right, let's apply our uppercase waSCC. It says we've got a created pod. Pod started. It's running, so let's curl it. I think I missed something in, oh, I did. I missed changing the version in our container spec. So this delete takes a bit of time because it's removing the actor from the WASC runtime instead of just deleting a pod, because we've got a runtime for WASC here. And if I want to be lazy and not wait, I can just stop this and delete my node. Force delete pod, which was already gone anyway. All right, let's run again with the new version. It's pulled the container down, or pulled the WASM down from the container registry. And now we can make a call to it. All right, so original was query string, uppercase is uppercase query string. That's awesome. So let's see if logs work. I don't remember what we logged. Oh yes, we logged the query string. So you can see kube control logs work because we added log support to WASC a week or two ago. And that's really awesome. So at this point, we've got a pod running in Kubernetes called uppercase. And we've got logs from the pod. We can query it using HTTP. It returns a response that has the query string uppercased. And thankfully, Kevin came in and told me how to get this OK thing right, because I probably would have spent all day looking for the question mark that didn't exist. The last thing to do is clean up the docs here, and now I can make a pull request against the Krustlet repo. And that Krustlet repo is here at github.com/dslabs/Krustlet. If you want more information about WASC, you can go to wasc.dev. And don't forget to follow me on Twitter at bkettleson, on Twitch at bkettleson, YouTube bkettleson, pretty much bkettleson everywhere. I appreciate all of you tuning in to watch this. It was a lot of fun making a WASC actor and running it in Kubernetes. That's pretty serious business right there. So thanks, everyone. Take care.